Hello, everyone, and thank you for joining us for our newest installment of our Men&Mice informational webinars. This one is on Windows Server 2016, going over what's new in DNS, DHCP, and of course IPv6. My name is Paul Terrell. I'll be your host, more actually the facilitator, and I'm here with my colleague Carsten Strothman, who's with the Men&Mice professional services team. He'll be doing the interesting part of this. A little bit of housekeeping. We will be taking questions. So if you just want to use the question functionality of the GoToWebinar, I'll be collecting these questions and then at the end submitting them to Carsten. So we'll have a good, meaningful QA session. This is also being recorded, so everybody in attendance or everybody that signed up will also be getting a link so you can watch it at your leisure. So without any further ado, I'm going to hand over control to Carsten. And again, I do encourage any questions, and we will address those at the end. So Carsten.
Thank you, Paul. Hello, or welcome everybody to our today's webinar on Windows Server 2016. So what we have today is a lot of DNS and a little bit of IPv6 and DHCP, because the most changes that have been seen so far on the new Windows Server has been in the DNS space, and there are some very exciting changes there. A big part is DNS policies. We'll cover that in details and give some examples, for example, how to do application load distribution with DNS and DNS policies. Then we have a little bit IPv6 and DNS with the support for IPv6 routines in the Windows Server 2016 DNS Server. Some new DNS records being supported, especially the DANE records, the TLSA records, and also support for unknown DNS records. I will show how that works. And by looking in the internet preparing this webinar, I found that there's almost no information available currently how to really use these two new features. So it might be a first here where you can see how you can actually use these new features here. Then we look into response rate limiting, which is another feature, and I will cover at the end some of the other features which are not directly DNS or DHCP or IPv6 related, but probably will help if you run a DHCP server or DNS server. All the features that we show here are based on the Microsoft Server 2016 Technical Preview number 5, which has been released in April this year. And the release date for Server 2016 is set to Q3 this year. So we hope it's almost the final set of features that we see here. Of course, there might be changes between now and when the final product is being released. So first we look at DNS policies. And DNS policies is a very powerful way to control how your DNS server answers to queries. It's similar but more powerful than the views in Bind 9. Basically what it gives you is the ability to control what DNS answers a DNS server gives, depending on where the answer is coming, or where the query is coming from, what's in the query, like the domain name being requested or the record type being requested, from which geographic location the query is coming from, and you can even have filters on time of the day, and we will go into that in a moment. You can do all kinds of interesting deployments with this. Most importantly, it now enables operators of Windows servers to have access control for the resolvers, to prevent open resolvers. In the past, it was only possible, at least with the usual tools, to enable or disable DNS recursion altogether, but not to do it in kind of a way that you enable DNS resolution for certain kind of IP addresses, like for your own clients, but deny it for the whole internet. That resulted in quite a number of open resolvers running in the internet, running Windows Server, and this is now being rectified much better now. People can, and DNS administrators can tighten down the access control on the DNS resolvers. You can use DNS-based load distribution. We'll show an example of that. We can black hole malicious clients. Maybe we have no means to really fix the client, but we see a client that is sending malicious queries, and we can just black hole that and don't answer query to him. We can filter based on domains and query types, and we can even do split brain DNS configurations. But I've written here caution because you should really know what you're doing if you do a blitzbrain DNS configuration, because it's an easy way to get into trouble. It can be useful sometimes, but before designing a split brain DNS configuration, make sure that you weighted all the pros and cons of such a deployment. So how does DNS policies work? Every DNS zone can now have one or more zone scopes, and every zone scope is like an extra copy of the zone. It is like having different content for the zone. So it's like you have on your server multiple copies of example.com, the zone, which each is living in its own zone scope. And each zone scope can have the same data or different data. So you can have different A records with different IP addresses, different quad A records, different MX records. Everything that can live in DNS can be different between the zone scopes, but they are still having the same names. And the DNS policy then defines which scope is being used when a query is coming in. The selection of the zone scope can be based on the client subnet, so from which source address the query is coming from. It can be on the transport protocol, which can be either UDP or TCP, internet protocol, which can be either IPv4 or IPv6, the server interface IP address, so if you have multiple network interfaces on your server and there can be queries coming on different interfaces, like the internal interface or the external interface. You can select that as a criteria. You can have a FQDN, a full qualified domain name, as a filter, and wildcards are possible here. You can filter on the query type, like A record, quad A records, MX records, and so on, and time of day. So you can give like different answers during daytime than during nighttime. And what makes it really, really powerful is that you can have multiple of these criteria and you can combine them with Boolean expressions like and, or, and not. So these DNS policies can be very, very, very powerful, but also they can be getting quite complicated. So you should be careful, because then troubleshooting DNS with a very complicated policy is also not much fun, because you see all the kind of different answers, and you have to know the policies on your DNS server to really be able to interpret what's coming back from your server. So let me show you a real-world example of the policies, and this is about restricting DNS recursion to subnets. Before we go into the configuration of the policy, I'm setting up a new zone here. And I'm creating just a new zone called example.com, a simple primary zone. And I will use that example.com zone during the course of the webinar as the example. Now example.com zone is being created, and now I'm adding DNSSEC, because DNSSEC will be important later on when we talk about the DANE records, because DANE records, in order to function correctly, need to be secured by DNSSEC. I'm using here just the default settings, which are the RC recommended settings for signing a zone. And now we have an example.com zone, and it's DNSSEC signed, and we can start with that zone creating a policy. So I'm starting here by looking at the DNS server recursion scope for dot, which is the default recursion configuration, which is by default on, meaning that everyone sending queries to the server will get DNS recursion. And I'm trying that here from my MacBook, sending a query to the Windows 2016 DNS server asking for Men&Mice.com, and sure enough, I'm getting the IP address here from Men&Mice.com. What I will now is I will restrict the policy so that not everyone gets recursion, but only certain IP addresses. So first step is I disable recursion on the global scope, on the name dot, which is the default policy. So enable recursion is now set to false. And now when I'm asking for a name which is not in the cache, like Men&Mice.is, I'm getting a server fail. So the Microsoft server is denying recursion and it's not in the cache. So I'm getting a server fail here. So in this state, everyone, every client, no matter from which IP address the client is coming, getting this server file. Now I'm adding a client subnet. Now first I'm adding a new recursion scope. Give it a name for my clients. And on that, recursion will be enabled. We have now two DNS server recursion scopes. One is the global one with the name dot, where recursion is disabled, and one with the name my clients, where recursion is enabled. Now I'm defining a client subnet, and here I'm defining a /32 subnet just for my one client, which is my MacBook. But I can do any kind of subnetting here. So it can be a /24 or /16. It can be done with IPv4 and IPv6, and you can even have multiple IP subnets in there. So this is just for the IP address, for the single IP address of my MacBook. That client subnet is now generated in the server, and now I'm combining the recursion scope with the client subnet by doing a query policy. So the query policy gets its own name. And the action on the policy is to allow communication, that we allow DNS recursion here. And it's applicable on recursion, meaning if there's a query coming in and it has the RD bit set, the recursion desired bit set, this policy gets into action. The recursion scope for this policy is the my client scope. And then I will combine that recursion scope with the defined subnet. So with the client subnet of test client. Here we have the filter expression. The EQ means equal, and it means that if the subnet is equal to test client, this rule will get into action. And I can list multiple client subnets here. Now the new query resolution policy is in place. Now I'm testing that policy. And I have two machines now, one with the IP address of 25, one with the 27. Now the machine with 27 is in the policy. So the machine with 27 is allowed recursion, while the machine with 25, which is on the top, is not allowed. So I've just sent a request for men&mice.com, and the machine with 25 IP address gets a server fail. Now if I do the same on the other machine, which is the 27 machine, which is in the policy, I'm getting the response back. I'm getting the IP address back. And that's a simple mechanism to create an access control for your DNS server. Basically, you define all your local client subnets that should get recursion services, and then you define a query resolution policy with all the subnets denying requests from everyone else. So that was the first demo. And here we have the PowerShell commands that I used to create this demo. So first I looked at the DNS server recursion scope for the name dot, which is the global one. Their enable recursion was enabled or true. I then disabled global recursion and created a new recursion scope named clients. I then added DNS server client subnet. Here in this example, it's a full /24 subnet. In my example, I used just 32 for one machine. And then at the bottom, we have the query resolution policy that combines the recursion scope with the client subnet. On the second demo, I will show application load distribution using DNS. So in this demo, we work on the example.com zone. And here I'm adding a zone scope. And the zone scope is like a different view in bind terms on the zone example.com. So it's for the zone example.com, and the scope name is named scope 1. So the name is just an identifier. You can use any kind of names for your zone scopes. And I'm also creating a second one called scope number 2. So now I have actually 3 zone scopes for example.com. One is the default, which is always there. It's like the zone that you can see in the DNS server snap-in. And then there are 2 other scopes, which are called scope 1 and scope 2. And we see them if we use get DNS server zone scope on example.com. Here we see there is the zone scope example.com, which is the default created by the snap-in. And the file name backing that zone is example.com.dns. And then we have 2 other scopes called scope 1 and scope 2, which have their own files, which are their own master zone files. Now I'm creating an A record inside scope number 1. And I'm doing that with PowerShell because currently with the DNS snap-in, with the GUI tool delivered with Windows 2016, we can only see the default scope, which is the example.com DNS scope, but not the extra scopes that I'm created. So the IP address of www.example.com should be 192.0.2.10 in the scope with the name scope 1. And then I create in scope number 2 the same entry, the same www.example.com, but with a different IP address with 192.0.2.20. Now we have 3 scopes, one which didn't include any www entry, and scope 1 and scope 2, which include the www entry with different IPv4 addresses. And now I create a query resolution policy. And this is the load distribution policy. Load distribution in contrast to load balancing, because there's no real feedback channel between the DNS server and the application. So the DNS server doesn't know whether the application is alive or whether the application is overloaded. It's just distributing the IP addresses to different application servers. So this policy is for example.com. And for the scope, we're defining here scope number 1 should be used for the first 4 queries, and scope number 2 should be used for the 2 next queries. So query number 1, 2, and 3, and 4 are going to scope number 1. 5 and 6 is going to scope number 2. So we have roughly a 75% to 25% load distribution. And this resolution policy should go on the server interface IP, which is the IP address of the DNS server. Now the policy is being defined. Now we can list them. So there's the scope load distribution policy. It has processing order 1 because there can be multiple policies on a zone, and then the processing order defines in which order they are being used. And I'm going back to my MacBook and showing you the result of the policy. Now, if I'm digging for www.example.com towards the Windows DNS server, I'm getting back the IP address from scope number 1, which is the .10 address. And I'm doing that 3 more times. I'm always getting back the 10. Sorry. And now for the next time, I'm getting back the 20. The 2 times I've now at the 20, and the 7 times I get the 10 back. So it's now giving me the IP addresses 4 times the .10, and then 2 times .20, and then 4 times .10, 2 times the 20, and so on. And that creates a simple load distribution for the application here for the web server on www.example.com. Here are again the PowerShell commands that have been used. First creating 2 scopes, then showing all the scopes on the zone example.com, then creating the 2A records in scope number 1 and scope number 2, and then combining both scopes in the query resolution policy. And the important part is here the zone scope. This one, this string, defines how many queries should go to scope number 1, how many queries should go to scope number 2. And this is just a very simple example. It can be even more complicated than that. And you can maybe have load distribution, and then based on different time of the day, depending on where your customers are coming from, have different load distributions between Europe and US and Asia, for example. So that was just a tap into the policy. There's much more, and I encourage you to look deeper into that. In the show notes for this webinar, we have additional links to resources where you can find more examples about how to use the policies. Another change on the DNS server is that the DNS server now comes pre-populated with the IPv6 IANA root hints. The root hints is the information for every DNS server to find the start of all DNS resolution, to find the root name servers in the internet. Up until Windows 2012 R2, the server only contained the IPv4 root hints for the internet. However, it was possible to add the IPv6 root hints, but they just weren't there from the beginning. So you had to do that manually. Windows 2016 comes with all the IPv6 root hints pre-configured. That enables the server to run in an IPv6 only network. And yes, that's more common than you might think. There are a couple of data centers right now that run IPv6 only, and they have some IPv4 to IPv6 translation services at their border gateways. But internal in the data centers, it's all IPv6. And in order to run a Windows DNS server in this environment, it requires these root hints. Then we have support for the TLSA resource record. And TLSA resource record is required for DANE, which is DNS Authenticated Named Entities. And this is a way of pinning TLS SSL certificates via DNSSEC Secure DNS. We had a previous webinar on the details here called DNSSEC and DANE Email Security Reloaded. And if you want to look deeper into this, here's the link, and the recording is still there for you to watch. In a few words, how DANE works is that if an application makes a contact to a remote server and that server offers security by encryption, the server is sending his certificate over, and the client can then check in DNS whether the certificate is really meant to be used by this domain name by looking into the DNS, because the DNS either contains the hash of the certificate or even the full certificate itself, and the client can then compare the two. In order to use DANE, it's important to be able to store certificate information in DNS, and that is done with the TLSA record, which is now supported by Windows Server. And here we have a demo on how that is done. Oh, wrong demo, sorry. This video here. So here we have our example.com zone. And currently it doesn't contain a TLSA record. And this is the PowerShell command to add a TLSA record. Currently it cannot be done with the GUI part. The name is _25 _TCP for a mail server. And we then specify the parameters for TLSA. Here it's a domain issued certificate with matching type SHA-256, and the selector is the subject public key info, meaning that the hash is just built on the subject public key info part of the certificate. In DNS terms, it's the parameter 311 that we see here, and then the certificate association data, that is the hash of the certificate itself that is stored on that mail server. So the PowerShell command now has created this record in the DNS, and if we reload our GUI snap-in from the server, we now see there's a subdomain _TCP, and in there's a name _25, and we can see it's of type 52, which is actually the TLSA record, and we have the binary data in here. So the Microsoft snap-in currently doesn't show the TLSA record. Maybe that will change before the release, but in all cases the Men&Mice suite will, in the Men&Mice GUI, show the real TLSA record and will allow you to edit TLSA records directly without handling the binary stuff. And if I send a DNS query with the dig command for _25._TCP example.com record type TLSA, we get back the TLSA record of 311 and the hash of the certificate in here. So this is great for everyone that uses DANE, which is especially popular currently in Germany, with the most biggest mail provider have switched already to DANE. Then we have support for, here again is the command how to add the TLSA record for your reference. And then we have support for unknown resource records. So in the past, the Microsoft DNS Server only supported a handful of the DNS records available in the DNS protocol. Quite a number of DNS resource records have been standardized, but only a subset of these have been implemented in the Windows Server. And if someone wants to use, let's say, any record not supported, a Microsoft DNS Server administrator was out of luck, because there was no way to bring in these new record types into the Microsoft DNS Server. This has not changed. The new server now supports any kind of DNS records, because you can specify them in a generic format. There's an RFC of how to handle unknown DNS resource records, and the PowerShell commands being used to provision the DNS server use a very similar, not the same, but a very similar format that is defined in this RFC. Examples for record types that someone might be used, which are not by default being supported in DNS Server 2016, is the URI record type, which I will use in my demo, the SMIME or OpenPGP key for DANE, or TA or TA link for Trust Anchor provisioning. So we can now put in any kind of record types into DNS, but we have to give the record data in hexadecimal notation, and that might be a challenge how to get to this hexadecimal notation. Fortunately, there is a bind9 utility called named-RR checker that can be used to convert the clear text, the human readable part of a DNS resource record, in its hexadecimal format. On the bottom of this slide, for example, I have the information how to create an A record, but not in the usual form of an A record, but using the generic format. It's with the PowerShell command add DNS server resource record of the name ... in the zone example.com. An A record is actually type number 1, and the record data here is hexadecimal 0A000001, which is equivalent to the IP address 10.0.0.1. And if you put that into the DNS with PowerShell, like here, and then you open the DNS snap-in, you will see a normal A record, and the IP address will also be shown in its normal octet format. So a demo on the unknown resource records. And in the demo, I'm using the new URI resource record. The URI resource record is rather new, and it allows supporting applications to map a domain name directly to an URI, which is a more generic form of a URL. Here, for example, it's an HTTP URL server and the path. So here I've used the named-RR checker to create the hexadecimal data. It's of class 1, which is the internet class, type 256. That is the record type. And then we have 31 hexadecimal characters. And I'm using add DNS server resource record command to put this record into the DNS. I don't define the type directly, but I give the name. The name for the URI is very similar to the SRV records. It has the service name and the transport protocol. Here it's _HTTP_TCP. The zone name is our example.com zone. The type is type number 256, because that's the type number for URI. You can also look up the types in the IANA registry, which is a public registry where all the standardized DNS record types are listed. And then the rec data, that is the hexadecimal blob, and it's too cumbersome to type, so I'm pasted that in. So enter. And now the record is in the DNS server. When I do a refresh, I see that in the snap-in. And we see here it's of type 256. It's the size is 31 bytes. And here we see in the hexadecimal value, it has the priority of 10, a weight of 1, and we can clearly see the URL http://example.com/path in here in the char value. So here are again the commands if you would like to test it yourself, and the link to RFC 7553, which is the RFC that defines the URI DNS resource record. Before you get too excited about using URLs and mapping domain names into HTTP URL path, that seems to be quite useful, except that there's currently no browser application that supports the URI resource record, so it's too new. Has just been standardized end of last year, so maybe in a few months' time, Firefox, Internet Explorer, Chrome, etc. will hopefully support the URI, and then you can make use of it. Then we have response rate limiting, and this is about mitigating the risk of DNS server being misused for denial of service attacks. That has been a problem for a long time. It has been known by DNS experts since the beginning of DNS, but this kind of attacks has been seen especially popular in the last 5 years, and this is the reason why Microsoft is now doing something about it. We had a webinar on response rate limiting and the problems of DNS reflection attacks some years ago, and it's still online. Here's the link if you want to look deeper into the problem. Here's a short recap. So what's the problem? Most DNS traffic is stateless, it's UDP, so the source address can be spoofed. So the attacker here on the left-hand side sends a DNS query with a spoofed source address to some DNS server in the internet, which might be a Microsoft DNS server run by some customer. And then the answer, which is usually larger than the query, is being sent to the owner of the spoofed address, which is the actual victim of the attack, shown here as the thicker arrow pointing down. That's not a problem with just one query. It becomes a problem if the attacker will find a lot of DNS servers in the internet, and that's quite easy. You can just scan for port 53 and find a lot of DNS servers. It can be used for this kind of attacks. And then, because the answers are quite larger than the queries, the attacker can, with not so much bandwidth investment, create a huge denial of service attack against the victim. And the victim has actually not much way to mitigate this, because it's coming from all over the place, and it's not possible to filter that in the firewall. So the one solution here is called response rate limiting, and it's a solution that can be implemented by the owner, by the user of the DNS servers. Response rate limiting, or RRL, was first developed by Vernon Shriver and Paul Vixie, and has been implemented in Bind, NSD, NOT, and the Power DNS. And it's now also available in Windows Server. How does it work? It looks for identical queries that should not be seen from the same source inside its time to live. Because how the DNS works, every DNS queries from client should go to a caching server. And if the time to live of a DNS resource record is, let's say, 1 hour, then a caching server should cache that entry for at least that time or exactly that time, and if the client asks again, that query will be just served from the cache and will not be seen at the authoritative server. So if the authoritative server sees many recurring queries from the same source, let's say the same caching server, which in the TTL, that's likely an attack, or it's misbehaving software, but most often it's an attack. And then response rate limiting kicks in. Instead of answering every response, the server will throttle down the responses. It will only send a certain number of responses, less enough to not create a denial of service attack to the source address if the source address is being spoofed, and that allows still legit clients in the victim networks to still resolve DNS data. Because if we, instead of doing response rate limiting, would block all the communication, that could be then also used for denial of service attack against the victim. In addition to sending occasionally answers over UDP, the server also starts sending answers with the TC flag. And the TC flag forces the DNS resolver on the other side to resend the query over TCP. And because TCP is much harder or even impossible to spoof than real caching DNS servers, real DNS resolvers will be able to come through, while the attacker will be not able to come through. And here we see a graph of response rate limiting in action. This is on a scale of multiple gigabit per second, so it goes up to 2.2 gigabit per second. And at the date and time where the arrow is pointing, their response rate limiting was enabled on that server, and all of a sudden the amount of data that is being sent out has been back to normal. So now we look how response rate limiting is being implemented in Windows Server 2016 and how to enable that. We can query the status of response rate limiting with get DNS server URL, and by default response rate limiting is disabled, so mode is disabled. So let's enable that. We can do that. Oh, now first we try to launch kind of an attack. Here I'm using the perf tool from Unbound to send one query, it's always the same query for a DNS key resource record, as fast as possible to my Microsoft DNS server. The server is running in a virtual machine, not very powerful, so we get only around 13,000 queries per second back. That's okay. It's still quite a number of data that is coming back here. And now let's enable response rate limiting. We set DNS server URL. Mode enabled. Asking me yes if I want to really enable this. Now if I query the status, it's enabled. And if we now go back to the attacker's machine and launch this very same attack, we see there's 1022 queries coming through and then nothing. And then occasionally it's another 10,000 something queries coming through and then nothing for the next seconds. And if we compare that with the setting, the maximum response per window here is 1024, and the window size is 5 seconds. And I'm now changing the maximum responses per window, which is per 5 seconds, to 200. And there's a warning here about response rate limiting to be disabled on the server. This is probably an error in the early technical preview, because it's not disabled, it's still enabled, but now with the maximum response per window of 200. And if I now go back to the attacker's machine and call the command, we see roughly 200 queries coming through, then for the next 4 seconds, nothing, then another 200 queries, 4 seconds of nothing, and then another 200 queries. So that's an easy way to enable response rate limiting. The default parameters are quite okay, but before you enable that on your own infrastructure, be sure that you do some testing, know your amount of queries coming in, and maybe you have some kind of maybe misbehaving application that sends a lot of duplicate queries that might then be rate limited or getting into problems. So before enabling this, be careful and monitor your DNS traffic so that you don't shut off any legitimate clients of yours. It's also possible to whitelist certain IP addresses or even full subnets that they don't get rate limited at all. And you maybe should do that with your own internal client networks. So, other changes and use. In DHCP, there has not been much changes in this release. The only change that has been publicized so far is that the network access protection has been removed. Network access protection was a way to for the DHCP server to detect whether the client has the right security configuration, like virus scanner installed, and that has been removed. That has already been deprecated in Server 2012, and now it's been removed. There's containers with Docker, and that allows lightweight separation of application on a single server instance, and that can be used, for example, to host a separate DNS and DHCP server on the same machine as maybe some other application, but shield the DNS server from the application, or even have multiple DNS servers on the same machine shielded against each other. Later this year, we will have a webinar on Docker, both on Docker with Linux and Docker with Windows, and we will show how to install the DNS servers in a Docker container there. Then there is Nano Server, which is a very, very minimal server installation without a GUI and without a lot of other stuff that is usually in Windows Server 2016. It can be used to create a very, very lightweight DNS server deployment. There's basically nothing much running than the Windows kernel and then the DNS server application and some very restricted libraries that are required for management. Then Windows Server 2016 has software-defined networking and layer 4 load balancer. That can be used to load balance DNS traffic. For example, if you have in your environment multiple DNS resolvers and you want to make them high available, you can do so with the load balancer. And we will have also a webinar on using the load balancer later this year. Release dates. Microsoft has told us that they will release Windows Server 2016 in Q3 2016. Men&Mice has decided that Men&Mice Suite 7.3, which was due in September, will support this new release. And we plan to have many of the new features, maybe even all that I've shown today, be supporting the GUI and the web GUI. So even if Microsoft doesn't ship a GUI component for, let's say, creating TLSA records or creating unknown resource record, can use the Men&Mice GUI to do that. So before we come to the question and answer section, short lookout to the next upcoming webinar, which will be on Yeti DNS. Yeti DNS is an international research project on the DNS root server system. There, people around the world test alternative ways to run root name servers. We will have an interview, which is the first time that we have an interview in this webinar series with Shane Kerr from BII, the Beijing Internet Institute, who is one of the main participants of the Yeti DNS project, and he will tell us about the project, what the project goals are, what research they have done, what experiments they have done so far, and what are the results, and how you can participate. And also in that webinar, I will show how you can participate with your own DNS resolvers in that research project. So that concludes the Windows Server 2016 webinar. Do we have any questions?
We did receive one question, Carson, and you actually just addressed it, but I'll repeat the question. How much of the new functionality shown can be done through the DNS Microsoft Management Console GUI? Most of the demos are shown using the PowerShell commands. Is that the only choice, or can it be done with the CLI? And of course, can it be done using the Men&Mice DDI product?
Yeah, so far in technical preview number 5, all the new functionality is only available from the command line. So using PowerShell commands, there's no support. At least I haven't found anything in the DNS snap-in. However, that might change for the release version. If it doesn't change, Men&Mice is committed to help, and we plan to support many of the new features also from the GUI.
And it was also a point of clarification or correction, as it were, that the Men&Mice DDI Suite version 7.2, which was released today, already does support RRL in 2016, and other features which are the same in Windows 2012 are also supported. So I want to point out that with today's release.
Good.
Are there any other questions from anyone? Okay, if not, I did want to reiterate the upcoming webinar on June the 9th, as Carson just mentioned, the Yeti DNS webinar, which will be really interesting as well. Again, everybody that signed up will get a link to this webinar, which has been recorded. If anybody would like any further information, or if they have any follow-up questions, they can feel free to email me. My email address is pault@menandmice.com. It will also be included in the email you get with the link to this webinar. So if you have any questions about today's webinar or the Men&Mice suite of DNS, DHCP, and IP address management products, please feel free to reach out. Otherwise, thank you all for attending, and thank you, Carson.
Thank you. Have a good day.